Welcome in. Thank you for being here. Grab a notebook, pen, or pencil. Whatever you want to write with is fine. This is math from the void. Math coming at you out of nowhere. Today we got a problem from the 1996 AP Calculus AB exam. Now you might want to grab graph paper, but it's not necessary. You'll notice that I marked up the given graph a little bit just because the print, or I should say the screenshot, wasn't very clear, especially when I enlarged it. So, just to break things down a little bit, they've very graciously told you in many different ways that the derivative of the graph is given here. So they marked it here. They told you that y equals f prime. They've made this very generous note here. This is the graph of the derivative of f, not the graph of f. And they've even mentioned the figure above shows the graph of f prime, the derivative of f. So if they haven't said it enough times, this is not the original graph of the function. The y values here represent the slope of f. Okay, so the slope of f. So we don't know what f exactly looks like, and you might want to grab graph paper possibly, because you'll have to sketch a little possible graph of the function. However, you don't need that much space. Really, you mostly just need like the x values that are represented here, so to go from -5 to 5 with some interesting thing happening in between along the way. So go ahead and pause the video, see if you can give this a shot. Give yourself, this one's a short one, so I would say give yourself like 12 minutes, 10, 12 minutes rather than 15, even though you'll be given an average of 15 minutes per question. Okay, let's take a look here. So the figure shows the graph of f prime. We've established that. And the domain of f is the set of all real numbers from -3 to 5, not inclusive. That's really important that it's not inclusive for when we sketch the graph of f. When we sketch it, it needs to not have a dot at x equals -3 or x equals 5. Oh, so it looks like it doesn't go out to -5. It looks like it just goes out to -3. Let's call that, I don't know, right here. Sure. So, part A. For what values of x does f have a relative maximum, and why? So we're going to kind of develop the why at the same time while we're answering this. A relative maximum means that it's like the top of a hill, right? The top point of a hill is a relative maximum. So what's going on with the relative maximum? We're looking for f prime to go from positive to negative, because f prime is the slope. So when we're drawing a hill, you have to go up the hill, and then you're at the top, and then you go down the hill. So the value of the slope is positive, which takes us up, then it goes to 0, and then it comes back down. So we're looking for that slope to go positive, which is up, and then at some point the slope goes negative, which means down. That's how we draw the maximum, the top of a hill. But remember that the graph they gave us is not the graph of the original function. This is the graph of the derivative. So we're looking for these y values here to go from positive to negative. That would be here. That's the only spot. That's the only spot where the derivative goes from positive to negative. Everywhere else it stays underneath. Here it kind of hits the 0, kind of bumps to 0, but it doesn't go positive. So it never goes positive to negative again. It kind of stays negative down here. All right, so that's the only spot. It's going to be at x equals -2. At x equals -2. Okay, part B. For what values of x, again, we're looking on the x-axis, does f have a relative minimum? Well, that's going to be a very similar thing, except we're drawing the bottom of a hill. And how do you draw the bottom of a hill? Well, we need the slope to go from negative to positive. And it is important that it goes from negative to positive, not just negative to 0. Because if the slope is going negative, which means it's going down, then it goes flat. If it doesn't come upwards, then that won't be the lowest point. If it continues to go down again, then this is not the minimum. See, it's not the bottom of the hill. It's the bottom and the top of a hill. If you're looking at it this way, it's the top. And if you're looking at it this way, it's the bottom. So that is not a relative minimum. It has to go down and then be coming back up. So in other words, we're looking for the slope to go negative to positive. Let's see when that happens. Oh, right. And since we're looking for f prime to go negative to positive, we're looking for the y values of the graph that's given, because the graph given is the f prime. Okay, when do we go from negative to positive? It looks like right here at x equals 4. So we'll say that it has a relative minimum at x equals 4. If you want to be very careful, you can say f has a rel min. And on the other one, you can say f has a rel max. I didn't really have space, so I just didn't want to stuff it in there, but you could do that to make sure that it's very clear what it is that you're indicating. And then here's the y, because f prime changes sign from negative to positive at that spot. Okay, great. As you can see, this one's pretty easy because we're just looking at the graph for the first few parts, just interpreting the graph carefully. Keeping in mind that the y values on here on this graph are the slopes. So we're not looking for when this thing is going downwards. We're looking for when this value is positive, that means the slope is positive, or when this value is negative, that means the slope is negative. Okay, let's look at part C, which says, on what intervals is the graph of f concave upwards? Concave upward, what does that mean? How do you know if something's concave up? Well, something is concave up if its second derivative is positive. Concavity depends on the second derivative. So if I'm at the level of f and I want to know the concavity, I have to go to the level of f double prime. If I want to know the concavity of this graph, f prime, I would have to go 2 derivatives forward. That would take me to f triple prime, and that would tell me the concavity of f prime. And if I wanted f double prime's concavity, I would have to go 2 derivatives up to the 4th derivative of f, for example. So we just want to know about the concavity of f, which means you go forward 2 derivatives. That's f double prime. And what is f double prime? Well, it's the derivative of f prime. It's like f prime prime. So it's the slope of the slope. It's the derivative of the derivative. It's the slope of f prime. We want to know when is the slope of f prime positive. Well, we have a graph of f prime. So we're basically trying to find out when is the slope of the graph positive. And now this is very easy to do now that we've broken the question down into way simpler terms. And it says use f prime to justify your answer. So that's exactly what we're doing. We're talking about things in terms of f prime, which is the graph we're given. Let's find when is the slope positive. The slope of this graph. So this time we are looking at the slope of the f prime graph. That's going to be from here to here, it's going up, and then from here to here, it's going up. So it's pretty simple. So when f prime has a positive slope, that means the slope of the slope is positive, which means the second derivative is positive, which means that the original function f is concave up. So we can just word that like this. We can say f concave up on the following intervals. Let's see, -1 to 1, that's what this is. I know it's kind of hard to read it. -1, this is 1. And also from 3 to 5. -1 to 1, union, +3 to 5. And we justified it because we're looking for when the slope of f prime is positive. Okay, now they give us some facts about f. F of 1 is equal to 0. In the xy plane provided, they would have provided like a little grid. Oh, and they just want us to show the general shape, draw a sketch that shows the general shape of the function on the interval from 0 to 2. So we really don't need that much graph at all. let's change this. Let's just have this go. This will be 1, and this will be 2. Okay, so what do we know is special about this? We know that f of 1 is 0. Okay, pretty easy. So that's correct for sure. What is the graph doing from 0 to 1? Well, in order to know what it's doing, we need to know what the slope is. And this is where we use the original graph, f prime. We can tell that from 0 to 2, from 0 to 1, we can tell that the slope of the original function, in other words, the y values of the graph, are negative, so it's going downwards. We also see that it's part of this concave up section, so it's going to be concave up but going downwards into this point. So concave up is happy face, but it's going to be going downwards, so it's going to be like this part. Like that. It was coming downwards. Yeah, it actually gets its steepest right around here at 0 from the looks of it. So I'll maybe have it go like that. And it's not to suggest that there's an asymptote there. It's just that, I don't know what the exact point is. And then let's see, is there anything interesting happening at x equals 2? Well, at x equals 2, we can tell that the y values here are still negative. So the slope is still negative for the original function, but the concavity of it now would be downward. And you'll notice that I pointed out this spot earlier. This is not going to be a minimum or a maximum because the function's derivative, in other words, the slope, does not go from negative to positive. It just goes negative to 0 and then back negative. So it continues to decrease some more, kind of like a cubic sort of thing. And so that's just a sketch. I don't know how far down it goes necessarily. I just know that it's going down like that. Okay, and I actually mentioned something incorrectly here. I said it's at its steepest at 0. Not necessarily at its steepest, because the steepest slope would be at this minimum slope. So it's just something that's like, it's really just, I don't know, it's going like that, and it's sort of going like that. And that's a perfectly acceptable sketch. It just wanted it from 0 to 2, which is strange. I'm surprised it didn't want it from like the whole interval. But that's the best that we can draw. What the heck is this little line? I don't know. I would put that's for part D. Okay, and of course there are tons of correct answers. The steepness that I used doesn't have to be the true steepness. It can be like, you can do it like that, or you can do it even flatter. It doesn't really matter as long as it's going downwards, which connects to the graph of f prime, and also it's concave down from 0 to 1. Concave up from 0 to 1, because it's on this interval from part C, and concave down on the interval from 1 to 2, because that's when it's concave down. Alright, that's enough blab out of me. I'll see you guys next time in the void.